So let's look a little more into what we can do with this instantaneous rate of change. So if this blue curve here is our function f of x, and we pick 2 points, p and q, x1, y1, x2, y2, then the change in y, the rise here, is y2 minus y1. The change in x is x2 minus x1. This is the run of this. And so the slope of this diagonal line here will end up being our average rate of change. Right? So m is delta y over delta x. Right? In this case, we could say that this is going to be f of x2 minus f of x1 over x2 minus x1. Right? That's one way we could look at this. Another way we can look at this is, in this other notation here. So here we have x comma f of x is this point. X plus h comma f of x plus h is over here. So what we're sort of saying there is, here's our starting place x. Over here is we stepped forward by the amount h. So there's a distance h between here. So it's the exact same picture, exact same setup. We're just using an alternate notation here, right? If what we want to do in either of these pictures here, our goal is to know what is the slope of the function right here. What is the slope of this tangent line? And how can we get to this tangent line right here? Right? How do we make our way to that? Well, I'm going to switch over to a different picture here. This one's in Mathematica. So here, this blue curve is our function again. Hopefully, there's the cursor. Right? So this blue curve here, this is our function, f of x. Right? And things are named a bit differently, but down here is our, say, x comma f of x. This is our p. This is our q. Right? And so how can we get down to the actual slope of the function right here at this point, x equals c, comma, and y equals f of c, at this point down here? Well, if we take this second point and we start moving it closer, you can see that the line gets closer and closer to being what we would call a tangent line. Right? Until at this point, it's exactly the tangent line. Right? So we could do that coming from the right. We could also do it coming from the left side as well. Right? We could start with c plus h being to the left, and we can move closer to c. Right? So there's all sorts of options there. But from both sides, we want to sort of squeeze that in and eventually get to precisely this right here. But this is just a limiting process, right? This slider here that I'm using is letting h approach 0. And when it actually hits 0, we get the tangent line here. That means for the slope of a tangent line, we can set up the slope for the secant lines, which we get from our average rate of change, and then take a limit as that second point approaches the first one, or take the limit as h approaches 0. So moving back over here to our notes, we can write down a definition now. The definition, we could say the tangent line to the curve y equals f of x at the point, I'm going to keep the notation from here, at the point x1, comma f of x1, has, or let's say this, is the line through, since we're defining the tangent line here, it's the line through this point. So whatever this point is, with slope m equals limit as x2 approaches x1 of f of x2 minus f of x1 over x2 minus x. All right, so this is saying, x1, f of x1 is the point we're interested in, right? That's this point over here. What we're doing is saying, all right, well, we're going to move out to any other point x2, and then we're going to keep letting that get closer and closer. Okay? That's the idea. Alternatively, another way we can write this definition, so I'm going to steal this text again here. Duplicate this down here. All right, another way we can write this, and this will kind of make our notation a little cleaner here. Let's erase all the extra stuff here. All right, so at the point, I'm going to use a, f of a this time. So tangent line to the curve at this point. In the dynamic picture I used, it was C, but it doesn't really matter. So it's the line through this point. Right, so the line through a, f of a. Now this time the slope is f of a plus h minus f of a over h, and then we take the limit as h goes to 0. So they both of these definitions here, sometimes one's easier to use than the other. We could always use either one, though. And again, what I really want to emphasize here is both of these expressions here are ways to compute delta y over delta x, or delta f over delta x, however you want to look at it. Right? They both get us to the same place. Right? So this limit construction here, taking the limit of the average rate of change in the appropriate way, gets us to the actual slope of the function. And that's how we can graph tangent lines. Or get equations of tangent lines and then graph them.